All right, so let's spend just a second talking about solving inverse trig things, or trig things. So say I had tangent of x is 1, and I wanted to solve this. So a bit ago we built the graph for tangent inverse, right? So we recalled that tangent looks like zebra stripes. Okay, so I'm drawing tangent of x, and I've got these kind of zebra stripes. And these continue, yeah?
Yeah.
Okay, where are the asymptotes occurring? Minus pi over 2, pi over 2, and then the next set is at 3 pi over 2 and negative 3 pi over 2. Okay, and then I'm trying to construct an inverse, right? Okay, so to make an inverse, what did I have to do? Yeah, we had to chop some of the graph because right now this thing fails the horizontal line test, right? So if I flip the inputs and the outputs, my graph would fail the vertical line test. So I got to kind of dump some stuff, right? So I said, okay, we'll dump this one here and this one here and just do our main zebra stripe, right? And so I'll get a new picture where I'm graphing tangent inverse of x. And this thing's, what's your range?
All real numbers.
Pi over 2.
Cool, good. So this goes down to minus pi over 2, up to pi over 2, right? Those are your old vertical asymptotes. They become horizontal, right? After I flip this thing. So that's, right, here's the line y is x, I'm trying to flip over. So I get a zebra stripe now that looks like this. And that's my inverse tangent. And we said, okay, good. The domain of inverse tangent is all real numbers. And the range is everything from minus pi over 2 to pi over 2. So what I found is that tangent inverse as a function takes all ratios of side lengths and turns it into what? Angles, specifically
less than 90 degrees.
Wait, I'm struggling with a symbol here. So they're definitely bigger than minus pi over 2 and smaller than pi over 2. And do I need the equalities or not? Yeah, I definitely don't want the equalities. Why don't I want the equalities? Good, because I don't know how to put 90 degrees into the tangent function, right? That's as evidenced by these vertical asymptotes I had at the tangent function or the horizontal ones on the tangent inverse. What's up?
Should we argue that it's greater than or equal to 0 because we can't have negative angles, so to speak?
I definitely can have negative angles. They won't sit in a triangle, but they will sit in the unit circle, right? Okay, so there's my tangent inverse function. So what I want to do is I want to solve this, right? And you guys are all on board with me just hitting this with a tangent inverse on both sides? Yeah? And getting x is tangent inverse of 1. You guys know an angle that has a tangent of 1? Yeah? So x is what?
2.
No.
Pi over 3.
So
Pi.
Is it just pi?
tangent,
Pi.
you're thinking what?
Sine of a
Pi over 6.
Should be thinking opposite over adjacent. So where's your angle that's got the opposite and the adjacent are the same? Pi over 4.
Oh, yeah.
You expect us to remember this?
Yes.
You're the worst.
That's for the
Sorry.
45, 45,
That is in the 45, 45, 90 triangle, right? The pi over 4, pi over 4, pi over 2 triangle. I would have also accepted pi over, I would have accepted pi over 4 or 45 degrees.
This equals
and then
45
it's 30 degrees pi over,
5 or
Probably.
6.
is it 6? Okay.
Yeah.
Because you're dividing 180.
Yeah.
6 times.
You can really think about pi radians is 180 degrees. So you really could substitute pi is 180.
Okay.
So my question is this the only angle that satisfies tangent of an angle is 1?
No, you can negative all of the other.
Negative pi over 4.
Yeah, shit, there's a whole bunch more of these, right? So really that's me going back over here to my graph of tangent, right? And saying, okay, where does this thing hit 1?
Every single time.
There's 1 right here. That's at pi over 4. You guys see that?
No, it isn't like
But there's a whole bunch more of those. So now my question is, how far apart are they?
One pi, right?
So how far is this?
1 pi.
1 pi.
I think that's 1 pi. Why do you think that's 1 pi?
Because they're being.
It's 5 pi over 4.
Good, because the period of the tangent function is pi. You guys see that? And so this way here, that's also pi, I think? Okay, so my answer is x is pi over 4, but that restricting domain thing, right? That's playing a little bit like the plus or minus in square rooting. How do I account for the others?
all of them.
Okay, I see that.
So I'm saying, all right, x is pi over 4. That's like right morally. Or like morally, I really mean it's the angle pi over 4. But maybe plus pi. So this is plus pi or 2 pi or minus pi. So I want to say this with n is some integer value. Sorry, the big Z is new, maybe. Is that accurate?
Yeah.
Okay, so another way to write this would be to write or with n is, and then make a list, and go, all right, it's numbers like -2, -1, 0, 1, 2, and so forth. This list is double-ended, right? And the fact that I'm writing a double-ended list makes me feel funny about it, so I just wrote a Z instead to mean the count, right? The Z is counting numbers, 0, and negative counting numbers. This thing's called the integers
Why?
because the German word for integer starts with a Z.
That's in kind of like a C with a line through it, but it makes an E, right? With the N. And
I thought that was a T.
Oh, this freaking thing. I'm sorry. This symbol means in.
In, okay.
Yeah, I'm so
In?
sorry. That's
In?
literally just a math way of writing the word in.
Oh, I thought that was a
In,
T.
like IN, like I'm
In.
gonna put something into
But-
something.
Yeah.
Yeah, but
Like
how
I'm
you
putting
write
the
it-
marker in its cap.
Yeah.
In.
You write that thing?
But yeah, it's like a C with the line.
Oh
through
yeah,
it.
it's just a C with a slash through
So
it.
why is yours a T?
So that is.
It is. I made it that way.
It is a cursive T.
It does look kind of like.
No,
It's a fancy
cursive
T.
T is this.
Yeah, that's basically what yours
Those are
looks
very
like,
different symbols.
except for sideways.
This is vertical. That's not.
Well, you were writing.
See the
backwards.
slopes? You guys should know about slopes.
This is not a
The
math
slope
problem.
on this one is positive, and the slope on that one is undefined at the top. They're very different letters.
No, they're not.
Okay, don't give me this. You're gonna have to sort it out from context.
This is all on the video too.
If you guys want to write it this way, you definitely can. Oh, with n, and that should also be n.
How do you write the Z? then?
Yeah, that looks better.
The z,
That's an extra line.
yeah. So the z is in this kind of blackboard bold font, which is
Like a 7 and then upside
like the
down.
R is this, Z is that,
With another line and a line through it.
Q is this one.
Wow.
Right, I'm just adding an extra line to make that thing bold. Because I mean the big, right, the big R, meaning all real numbers, or this one,
Wait, is
Q,
that
meaning
an
the
R?
rational numbers.
So you have a Q with an R and a line.
I'm just writing a bunch of these. There's a whole mess of them.
And what's a z mean again? What, in that
All
context?
real integers, right?
All real integers.
Yeah, so this one is integers. This is reals. This is rationals. The Q is because rationals are quotients. These are naturals. And the W stands for whole numbers, which I really never use. You guys know the difference between the whole numbers and the natural numbers?
No.
Zero.
Yeah.
Yeah, this one has a 0 in it, that one doesn't. Natural numbers are come up first if you were a cave person. Like, this is for counting sheep. This is slightly better than counting sheep because now I can account for not having any sheep. This is how you keep books, right? Because you need to account for debts of sheep. This is how you start splitting sheep among people. And this shit is how you start solving equations.
What?
And then this one
Or
is
how
when you
many
want
sheep
to
you lost.
break your mind and talk about how life really works. Cool?
What's that one?
These
Why
are
is it a
complex
sideways
numbers.
mountain?
Oh, yeah.
You're not using I?
No,
Those
yeah.
are
There's no blackboard bold eye.
Or
It looks too much like an H.
Oh.
Other things? Any questions about this?
imaginary numbers?
Yeah, that's these guys.
That's those, okay. Yeah, I don't like those.
They're super convenient.
They are.
Everything in the complex numbers is better. Okay, I'm just shutting this off.